Hello, everyone. A very good afternoon. My name is Suryansh Rana. I am the co-founder and CEO of Ethara.AI. At Ethara, we do one thing: reinforcement learning to fine-tune large language models. We are a team of over 3,000 experts. We process more than 50 billion tokens a month. And we have contributed over 6 million hours of high-quality training data to train the frontier models that we all use today. Now, you probably have never heard of us unless you build large language models. But today, I'm here to give you all a glimpse of what the frontier of model training looks like. Today's topic, from text emitters to thinking machines, covers the evolution of artificial intelligence from being these glorified chatbots or fancy autocompletes to something that can actually think, plan, act, and learn. We are also going to understand the role that reinforcement learning has to play in driving this change. Now, before we proceed further, I want to ask a seemingly simple question. Are the models today truly intelligent? To answer that, we'll have to borrow a framework from psychology: crystallized versus fluid intelligence. Now, this is not something that we came up with. It comes from the cattle horn carol theory of human cognition. And it applies surprisingly well to what we have built in AI today. Let me give you a quick example of what crystallized intelligence looks like. Let me bring your attention to this calculus problem on the screen here. Now, how many of us can solve this problem? Can I get a show of hands, please? Okay, quite a few of us. Let me rephrase this question. How many of us can solve this problem in under 3 seconds? That's a rhetorical question, right? We can't. But an AI can not only recall with high accuracy, but also apply with extreme precision the chain rule that is required to solve this problem and give us the answer in less than 3 seconds. Now, that is crystallized intelligence. The ability to recall with high accuracy and implement with extreme precision the knowledge that we have learned over a lifetime. And let me tell you, models today have gotten extraordinarily good at crystallized intelligence. Just how good? Let's take a look at this benchmark called Humanities Last Exam, or HLE. HLE was built by a group of domain experts, or PhDs, from various different fields. This dataset consists of some of the hardest examination-style questions ever created in the history of humanity. When released in 2025, the best models scored approximately 3% on this benchmark. But today, just after 14 months, the models have climbed to over 47%. That is a staggering rate of improvement based on something we call humanities' last exam. So it's safe to say that AI has kicked our human butts when it comes to crystallized intelligence. But let me ask the initial question again. Are the models that we use today truly intelligent? Now, you might think that this is another rhetorical question, but it's not. Let's find out. Let's take a look at fluid intelligence. Think of fluid intelligence as raw IQ or raw thinking power. It is the ability to solve novel problems without prior domain knowledge or experience. So here's what we did. Inspired by Arc AGI 3, we placed a human and an LLM side by side in a 2D puzzle environment. We gave them 4 controls: up, down, left, and right, and basically said, figure it out. The results? Humans took less than 10 minutes to understand the gameplay and solve the puzzle, whereas an AI could not even make sense of what it was looking at. And after trying for 8 hours, practically gave up. This graph, released by the Arc Foundation, depicts the gap in fluid intelligence between AI and humans perfectly. It shows how humans were able to solve this puzzle and achieve 100%, whereas AI was a flat 0. It is this gap in fluid intelligence that depicts the gap to AGI today. And it is this gap that we are bridging at Ethara. So how do we solve for fluid intelligence in large language models? Well, the traditional playbook relies on post-training. Techniques such as supervised fine-tuning and reinforcement learning through human feedback have built the models that we use today. They are great at teaching a model to recall, imitate, or even align with human preferences. But that's where the limitation is. Optimizing for human alignment does not train the model to do multi-step reasoning, use tools, or even learn from its own mistakes. These techniques produce polished outputs, not adaptive thinkers. And that's where the paradigm shift comes in. From preference to agency. In the old world, an LLM was given an input, which it processed and recalled from memory an output. Done. Static, one shot. In the new world, we are training these models to observe the environment, take actions, and learn from the outcomes, making these models more adaptive, robust, and capable of long-term reasoning. We are essentially transitioning AI from being passive text emitters to agentic thinking machines. Now, does anyone want to take a guess as to what is the engine that is driving this change? Any guesses? It's the one thing that we do at Ethara. Right. Reinforcement learning. But not the preference-based kind. We are no longer evaluating 2 model responses and selecting which one is better. No, that was the old world. We are actually building environments where AI can explore, take actions, and learn from verifiable rewards. That is what we build at Ethara. Now, before we train a model on agentic capabilities, it is important to define what agentic really means. Through extensive research at Ethara, we have discovered the 6 pillars of agentic AI: planning, tool use, reasoning, memory, perception, and self-improvement. To accomplish any real-world task that requires agency, requires a combination of all 6 pillars. Now, at Ethara, in order to train or test models, we needed a domain that uses all 6 pillars at once. The answer? Software engineering. Yes, software engineering proved to be the perfect testbed to assess models on agentic capabilities. Why? Because software development is inherently agentic. You read a spec, you plan an approach, you navigate a large code base. You also use tools to iterate, debug, and ship. It requires the exact kind of fluid intelligence that models lack today. Now you must be wondering that, hey, Suryansh, aren't the models already pretty good at coding? Well, the question is not if they are good at coding or not. The question really is, how good are they? So at Ethara, our research is focused on something what we call long horizon tasks in software engineering. These are not problems that you can solve with just a single prompt. Think of large-scale feature developments or refactoring a massive chunk of your code base. Something that would take your engineering team a full sprint to accomplish. I'm talking about 4 to 6 weeks of hardcore engineering. The closest benchmark that exists today is called SWE Evo. It's a great piece of work that evaluates models on multi-step code-base evolution. It covers 48 tasks in Python-only repositories. We took this as a starting point and built something bigger. Introducing Ethara.AI's MILO Bench. 50 real-world milestones pulled from large-scale open-source repositories, spanning 8 languages that your teams actually use today, such as Python, Go, Rust, TypeScript, etc. Now, this is not lead code. These are not isolated bug fixes. These are sustained, multi-file, multi-day engineering tasks. And the results? Frontier model performance decays exponentially as the number of change requests increase in the milestone. For example, when the number of pull requests are between 1 to 2, the model performs with decent accuracy, about 90%. But as the number of pull requests exceed 80, the frontier model performance collapses to 0. Let's just say that there still exists a massive gap between what these AI models can do today and what our engineers do every single day. So how do we solve for this long horizon gap? Well, at Ethara, we don't just throw more data at the problem. We focus on the feedback loop. It starts with the benchmark dataset, not synthetic junk. I'm talking about real-world complexity. The benchmark is run through a custom harness, which mimics a developer's environment. And we then perform model inference. But here's the secret sauce: rubric evaluations. We don't just care about if the code runs. We care about how the model got there. Did it plan? Did it self-correct when it hit a bug? This rubric rewards the thinking, and the feedback is looped back into the retraining process. This is training the model to value the logic as much as the results. And this is how you build long horizon thinking. We are not just training models, we are coaching them. So, to do what we do at the scale that we do it requires some serious horsepower. You must have noticed a number in the opening slide, 50 billion tokens. That was not a typo. That is what Ethara consumes on Amazon Bedrock every single month. Why Amazon Bedrock? When you are benchmarking the world's frontier models, you need three things: diversity, maturity, and scale. Bedrock provides the perfect playground to test everything. We use these billions of tokens to stress test models on crystallized intelligence, while also pushing them to solve novel, fluid problems. By leveraging AWS's global reach and EKS maturity, Ethara has managed to build one of the largest benchmarking engines in Asia. We are not using these tokens. We are practically burning them to find the breaking point of AI today so we can build the starting point for tomorrow. Thank you all so much. That's my time.